For this video to make maximum sense, I recommend watching my video on the basics of the Michaelis-Menten equation. So the problem with this is that this is our graph of V0 against substrate concentration, and the problem is that this line will never actually become horizontal, which sort of leads us to a problem. We can't properly estimate Vmax because this line will never actually become horizontal. So what two scientists did, Lineweaver and Burk, they decided to take the Michaelis-Menten equation and linearize it to plot it as a straight line so that Vmax could be more accurately determined. So if we write down our Michaelis-Menten equation, V0 is equal to Vmax what we do is we invert it, so that would become 1 over V0 is equal to Km plus S divided by Vmax times S. Now what we can do here is we can divide both these by Vmax, essentially writing it out in a different form. But mathematically it's the same thing. Now if you notice, you can cancel out the substrate concentration on both sides, so that gets you to 1 over Vmax here. Now this looks like something that could be converted or written in the form y equals mx plus c. So what we do is we write y equals mx plus c and compare our 1 over V0 plus Km over Vmax, substrate concentration plus Vmax. We compare this with y equals mx plus c, so that we end up with y being equal to 1 over V0, m being equal to Km over Vmax, x being equal to 1 over s, and c, the y-intercept, being equal to 1 over Vmax. So then, now that we know how to go about linearizing this is what our graph would look like. On the y-axis, it's 1 over V0. On the x-axis, it's 1 over substrate concentration. And plotting the line, it would look something like this. We know that the gradient is Km over Vmax. And we know the y-intercept is 1 over Vmax. And the x-intercept is negative 1 over Km. So this is actually very useful because we were able to convert something that looked like this, where we couldn't really tell what Km was very accurately, into something that looks like this, which is very useful because we can just take a look at what the y-intercept is, and that would tell us Vmax. And the gradient would give you Km over Vmax, and therefore you could work out Km for a reaction just by looking at this, and also the x-intercept is also 1 over Km. So this is very useful to be able to linearize the Michaelis-Menten equation. However, this does come with a few problems, such as when we have very, very large values of substrate concentration, that would mean 1 over S would be very small, which means that a lot of your 1 over S values would tend to cluster, but modern software is able to handle it. If you were plotting it by hand, you would probably end up with a lot of very, very tiny values for S if you had a large substrate concentration, but plotting it digitally would remove any error from doing so. There are other plots or other ways of linearizing the Michaelis-Menten equation other than the Lineweaver-Burk plot.